It is November, a full moon rises. Almost 400,000 kilometres away, planet Earth falls under its spell. Our oceans stir. An ancient undersea ritual is underway. The outcome of this event will not only affect marine life in the surrounding waters, but will also give us a clue about the health of the entire ocean system. The creature responsible is coral, and this is Coral's story. The story begins here with the incredible phenomenon that is mass coral spawning. It's an annual event cued by the sun and the moon. It involves over 140 different species and has been occurring for thousands of years. Although corals have no brain and no eyes, somehow individual species spawn together, sometimes down to the minute. Like tiny love letters, the genetic material is cast into the ocean currents, connecting reefs over hundreds of kilometres. Like us, corals take up to 9 months to prepare for birth. But many are hermaphrodites, so they gestate both egg and sperm. On spawning night, these are grouped into bundles and delivered through the coral's mouth. For most, it's a gentle birth. Over a short time span, the bundles break apart and the egg and sperm must find their counterparts from another colony. Billions set forth, but few survive. Many other creatures choose the same conditions to spawn, and the reef waters are transformed into a vast liquid womb, clouded with eggs and sperm. Mass spawning overwhelms potential predators, so the coral eggs have more chance to be fertilised and begin a new colony. By daybreak, vast slicks on the surface mark their passage. Coral is an architect not only of the undersea world, but above the surface too. Dead coral breaks down into sand that eventually builds up to create coral cays. These shores and shallows provide sanctuary and important breeding grounds for a variety of other creatures. All told, reef-building corals have colonised every tropical ocean, shaped and protected thousands of kilometres of coastline, and influenced marine evolution for millions of years. Birds like these noddy terns rely on coral reefs for food and coral cays for shelter. Birds help vegetate cays by depositing seeds, These seeds grow into trees and forests, which in turn provide the birds with nesting sites. These sandy outposts are frequented by many tropical seabirds, with some pairs returning to the same nesting sites year after year. Primitive corals date back over 450 million years. Modern reef-building corals first emerged around 250 million years ago, and their reefs have provided homes and sustenance for innumerable species ever since. Over corals' long history, 5 mass extinctions have come and gone. During each, up to 90% of all life forms perished. 2 of these extinctions occurred during the rise of modern reef-building corals. Rather than falter, they somehow survived, rebuilt their reefs, and transformed the oceans anew. Today, coral reef ecosystems are important nursery grounds for many iconic marine animals, such as the sea turtle. There are 7 species of sea turtle, and all are long-lived and slow-growing. They take between 10 to 30 years to sexually mature and mate at sea. These marine reptiles are nomadic and swim thousands of kilometres during their lives, but strong instinct and mysterious natural forces guide them, so that when a female needs to lay her eggs, she returns to the very beach where she was born to do so. Here she digs a nest, and coral sand becomes the womb. Hundreds hatch, but only 1 or 2 will make it to adulthood. They can then live for up to a century. When a turtle hatched 100 years ago, it would have seen the world's coral reefs in all their glory. Pre-industrial seas were clean and clear, and corals had enjoyed good conditions for millions of years. Throughout the Indian and Pacific Oceans and into the Caribbean and West Atlantic, reefs were thriving. The turtle spent its youth exploring these reefs and witnessed the engineering marvel that is coral. By harnessing the power of the sun and perfecting recycling, coral built energy-efficient cities that put many of ours to shame. Collectively, these cities created vast empires, some visible from outer space. Here, the turtle found itself in great company, for these undersea empires were home to vast numbers of marine species of every imaginable shape and size, and were crowded, colourful places. Today, reefs have one of the highest levels of biodiversity of any ecosystem, and are some of the most biologically important places on Earth. Together, turtles and corals have witnessed many changes to their watery world. They are some of the only beings to have survived the last mass extinction event 65 million years ago. Scientists predict that in the coming century, they will face ocean conditions as catastrophic as during that last extinction. Wise old turtles have seen the warning signs for a while. 70% of the world's reefs have already been destroyed or are seriously threatened. And all but one of the 7 sea turtle species are classified endangered or critically endangered. For the first time in millions of years, the future of both turtle and coral is uncertain. Many things affect the health of coral reefs, in particular sea temperature, sea level, and water chemistry. Reefs may look mighty, but corals themselves are fragile and can be fatally harmed by just subtle changes in their environment. When sea levels rise too rapidly, corals can't grow fast enough and reefs drown. As atmospheric carbon dioxide levels increase, ocean acidification intensifies and reefs will dissolve. And a sustained increase of only 1 to 2 degrees in ocean temperature can cause corals to bleach and die. By the end of this century, it's predicted that the global climate could be 5 degrees Celsius hotter or more. At this rate, bleaching will become an annual occurrence, and this colourful landscape will literally fade away. A healthy coral reef is easy to spot. A complex structure awash with colour, variety and activity. This is a tangled tropical garden to rival anything on land. Most amazing about this garden is that many of the plants are actually animals. Like grasping hands, coral mouths hungrily sift the passing currents for food, day and night. The creature we call coral is a primitive sac-like polyp, part animal, part plant. The animal part feeds on plankton. The plant part consists of microscopic algae called zooxanthellae that photosynthesize using sunlight. Each polyp is connected to its neighbour, passing along energy and nutrients. These polyps multiply to create colonies, which combine to form reefs. In this way, energy is produced, shared, and recycled throughout the entire ecosystem. With the energy they produce, corals not only thrive, but also manufacture calcium carbonate, the special concrete that builds reefs. This is one secret behind coral's great empire building.